Hi, everybody. Welcome to Shiko SAT Review Series. And we're going to start a new unit here. And this unit is we're going to focus on talk about the circles. Okay. And the circles is one type of the problem frequently, happen in the SAT exam. So we're going to do a detailed review about the circles. So in this unit, we're going to have two videos. And the first video we're going to cover and basically is the equation of the circle and how do we write the circle equation and how to interpret the equation of the circle. Then the second part of the circle, and we're going to take a look at the proportion among the arc length, circumference, sector area, and the whole area. How is that, if I want to find a certain arc length, how is the arc length related to the circumference? How is a certain area in the circle is related to the whole circle's areas here, okay? So those are the two videos we're going to cover here. So the first video, we're going to have these 5 problems and then another 2. So we totally going to have 7 problems to practice about the circle. And then after that, we're going to continue the video number 2. So the video number 2, we have another 7 problems. So we're going to work on the central angle, length of the arc, the sector of the area, area of the sectors, all those things here. Okay. So now let's start. So let's start our first part is how do I read the equation of the circle, or how do I write out the equation of the circle for the given information. Okay, so I'm going to go to the whiteboard now. Okay, so, before we start, and I like to, just like we did before, I always like to give a review, and so we know the key formula and the key skills we know we're going to have. Okay, so the first things we're going to take a look is the formula for the circles here. So you might want to have a notebook and try to take down the notes here, right? So here, the formula of the circle is something look like here. It's x minus h to the square plus y minus k to the square and equal to r squares here, okay? So here, the h and the k is here. So the number we use here, so h and k, this is what we call the center of the circle. Okay, and then the r squares here, the r, okay, so the r's here, we call this the radius of the circle. Okay, so the common mistake people make is these mistakes here. So make sure when you try to find the center, right? The definition here, this is x minus y minus. So the center is hk. If it is plus, then you need to change to the minus here. So let's say here, like let's take a look at some easy examples here. Then we can go to work on our word problem. So if I have x minus 4 to the square plus y minus 1 to the square equal to 9. So for these circles here, I know this is a circle, right? So this is x minus 4 to the square plus y minus 1 to the square. So what is 9? 9 is 3 to the square. So I know this one's here, the center is at 4 and 1, and the radius for this circle is 3, right? Because that's why be careful here. You need to change this number to the something squares, right? So radius is 3. Okay, so now let's take a look at another examples here. Just make sure you understand the formula for the circles, right? So if I have x plus 1 to the square plus y minus 3 to the square equal to 25 here. Let's make it a little bit, not 25, let's make it a little bit hard. Let's say here is 7 here, right? Okay, so the first thing here, I want to find the center, right? So here, this is x plus 1. Remember we say the key part for the formula here, they both need to be minuses, right? So here, this will be, you say x minus, because this is plus 1, so what you need to have is negative 1 squares, right? And then this is y minus 3 square. And the radius, remember, you need to switch it to something square. So 7th here, you know, the way we switch that, we say, okay, so this will be the square roots of the 7. Then you squared it, will be equal to 7, right? So after you rewrite it, and then we know, okay, the centers here. Okay, so the centers here will be what? The center is a minus, right? So it's a minus, so it's a minus what? Here and here, right? So the center will be negative 1 and the what? And the 3 here, right? So it's the value after your minus signs here, right? And what is your radius here? Okay, so the radius here is the square root of the 7, right? So that is your, so this is the r's, right? Okay, so also I'm going to mention so this is the key formulas, you know, make sure we remember that, right? And don't make a mistake. Like I said, the common mistakes here, or sometimes the examiner try to trick you, is they put a plus signs here. Okay, so the next things here I'm going to talk about in order to do the problems in this unit, we have another 2 formulas we need to know, all right? So the first formulas here is, we call this the distance formula. Okay, so the distance formula, that means if you have x1, y1, and x2, y2, those are the 2 points, right? Then the distance between these 2 points, yes, so we say the distance here. Okay, so let me try to change the color so that we know the distance here is what? The distance here is the square root of x1 minus x2 square plus y1 minus y2 square. I think this formula, I think most of you, when you finish the geometry class, you should all know these formulas here, right? So that's the distance formula. We're going to use this formula when we try to solve the problem in the unit, this, you know, in these circle units here. Okay, so the next formulas, okay, so really not is a formula. It's kind of like methods here. Maybe I will put a methods here, it will be easier. And we're going to use this technique here. And so we call this complete the square. Okay, so I think we all learned this in our algebra case. So how do we complete the squares here? So basically, so what we try to do, we use these formulas here. We say that a plus b square is equal to the a square plus 2ab plus b square. So we want to match, you know, we want to, for given equation, we want to have this form, then we can rewrite it to a square form, right? So that's what we mean, a complete square. Or this is a minus b to the square. This will be the a square minus 2ab plus b squared. So it's the same thing. We want to find the number and we need to match. So I'm going to show you how to use those things when we're dealing with different type of the problems in the unit, right? So remember, so we need the three formula, right? So the first one is the how to write the circle. That's very important. And then the next one's here, we might need to use the distance formula, how to, try to solve some circle problem. Then we might use a complete square method, right? Try to do it. Okay, so now let's take a look at our problem. So we always start with a very easy one, right? And then we go to gradually get harder. So the first ones here, they say a circle in the XY plane have a center 5, 7, and the radius equal to 2. Write the equation of the circle. So this is just a straightforward, right? So if its center is 5 and 3, we just apply we just apply the formula, first formula we talk about. And so what is the equation looks like? Will be x minus what? X minus 5 squared plus y minus 7 what? Y minus 7 squared and equal to r squares, right? So it's equal to 2 to the square. And or the 2 to the square is 4. So you can say the final answer, this one is x minus 5 to the square plus y minus 7 to the square is equal to the 4. That will be answers here. Okay, so now we're going to get a next levels here. So let's say write the equation of the circle, right, in the xy plane and with the given center. So, okay, so this one here is pretty cool. They give us the centers here. So I immediately know I can write my equation. This is x minus 0 to the square plus y minus 4 to the square, right? And this one's supposed to equal to r squared. So, but in here, they did not tell us the r squared. So what they tell us is here. So let's say there's a radius with endpoint with 4 over 3 and 5. So basically they tell us, okay, so here, let's see here. So that means, like they tell us here, I have a circles here, right? And the centers here, this is 0, 4. Okay, then I have a radius here. So the radius is like I have a radius and this point on this radius. This points here, this is 4/3 and 5. Right? So they did not directly tell us. So from here to here, from the center to any points on the circle, this is what our radius, right? So they did not really tell us what is the radius. They just say, hey, at the end of this radius, I touch this point, 4/3 and 5. So this is where I'm going to use the distance formula, right? Because I have 2 points. One is my center point, one is the point this radius is going to touch. So the distance between these 2 points, so this distance really is the radius, right? So based on my formulas here, so will be 4/3 minus 0 to the square plus 5 minus 4 to the square, correct? So it's x1 minus x2 square plus y1 minus y2 squares, right? So 4/3, so let's simplify a little bit. So 4/3 minus 0 still is 4/3. Squares will be what? 16 over what? Over 9. 5 minus 4 is 1. 1 to the square is 1. So here, this will give you, this is 16 plus 9 over 9. Find the common denominator, move the 1 up. So this one is going to be what? 25 over 9. Oh, that's pretty nice looking. So it's a 5 over what? 5 over 3. That's right. So it's a 5 over 3. And so now I can rewrite my equation. So this is x minus 0 will just be x, right? So this will be x squared plus y minus 4 squared is equal to r squared. R is 5 over 3 to the squares, right? So if you want to simplify that, so the final answer will be x squared plus y minus 4 squared is equal to 25 over 9. So you can leave either way. You can leave in the 5/3 of a square or 25 over 9, right? So it does not matter here, right? So this is the example we're going to use the distance formula, try to help us to find it. Okay, so now the next equations here is the next problems here. They say the equation x squared plus 20x plus y squared plus 16y equal to negative 20. And they say this is a circle. So what is the coordinates of the circle? So if this is a circle, so I know I need to change it to like x minus h to the square plus, okay, so I know I need to change it to the standard form I have here, right? So I need to change it to like x minus h to the square plus y minus k to the square and equal to r squares, right? So I need to change it to that form. But right now, they only give us x squared plus 20x plus y. So what I'm going to do, remember the completed squares, right? So here, let me try to show you how to complete the square. And then you can try to practice yourself by using next problems or find something else. Okay, so first, right, so I'm going to complete the square for the first part, the x part, right? So this is x squared plus 20x here. Okay, so remember we said complete the squares, right? I use this formula, a plus b. Let me different color so maybe it can show up. So you can see that better. So this is, we say a plus b to the square is equal to the a square plus 2ab plus b square. Okay, so when we do the complete the square, so the first things here, this is 20, right? So this is 20x. Because here is a 2ab, so you need to use the 20, you divide it by 2. So what is 20 divided by 2? It means, so if this is 20, you divide it by 2, this will be 10s, right? So you can rewrite this one like 2 times 10x, right? That's how do we complete the square. And then because this is 2x, 2 times 10x, so it's 2ab. So a is x. So what I need to do here, I need to add the b squares, right? So what is my b squares here? My b square is what? My b square is 10 to the square. All right. Okay. So now let's take a look at my y terms here, right? So this is my x term. Now I'm going to take a look at my y terms here. The y terms here, so this is the same thing. This is y squared plus 16y. So the same things here, I'm going to complete the square. So the 16y, I can separate that to 2 times 8, right? Y's here. So now it's a 2ab again. So this is my b's here. So what I need to do here, I need to do a squared plus 2ab plus b squares, right? So what is a b squared? It's a to the what? A to the squares, right? Okay, so now this is equal to negative 20. Okay, now in here, take a look here because, right? So because here, right? So take a look here because in here I add 10 to the square. I add a to the square. The original equation does not have these two numbers. So what I need to do here, I need to add the same amount on the right-hand side, right? So I need to add 10 square plus what? A to the square. That's how do we do the complete squares, right? Okay, so now now I finally can complete the squares. So let me do a color coding. So like for this ones here, for this portions here, right? So this is x squared plus 2ab plus b squared. So this part I can complete as x plus what? X plus 10 to the square, right? And then for the same ones here, for these portions here, this is also is a squared plus b squared and plus 2ab's, right? So these ones here, what I can complete, this is y plus what? 8 to the square. And now in here, my right-hand side will be negative 20 plus 100. So this one really is negative 20 plus 100 plus 64, right? 8 times 8 is 64. So this one's here is 80 plus 64. So this will add up to 144, right? Okay, so now this is my circle, x plus 10 to the square plus y plus 8 to the square is equal to what? 12 to the what? Squares, right? So what is the center, right? So remember the formula is x minus h, right? So this is x minus h and y minus k. So I need to change this to x minus. So this is x minus negative 10 to the square plus y minus negative a to the square is equal to 12 to the square. So now I know. So what is here? This is my h, this is my case, right? So the centers here, the hk is equal to what? Negative 10, negative 8. And the radius is what? Radius is 12. Right? So for the problem C's here, this is we use the complete the square methods here, right? So that's why we said on the, we're going to get very familiar with this. I know you learned the complete square in the algebra, so this will be a good way try to refresh it. Okay, so let's take a look at the part D's here. And I would recommend maybe you can pause the video right now and try to see you be able to do the part D by yourself and try to complete the square, then resume the video after you did that, and then come back to check the answers here. Okay, so now let's take a look at how do I do this, right? So I have this is 2x squared minus 6x plus 2y squared plus 2y equal to 45. All right. So because this is 2x, so I need to factor the 2x out. So this is x squared minus 3x. All right. So this is 2. This is y squared minus y equal to 45, right? So far, so good? Okay. All right. So now the next thing here, I can divide by 2 both sides, right? So I can divide by 2 both sides. So this is x squared minus 3x plus y squared plus y. And this is 45 divided by 2. Right? So from here to here is divided by 2 both sides, right? Okay. Now I'm going to complete the squares here. Let me rewrite here. We have a better space. So x squared minus 3x. Okay, so let's see how do I complete the square. So let's take a look again. So this one here is 3x. I need to change it to the 2ab. So this will be 2 times 3 over 2x, right? So that's what is my b's here, right? So it's 3/2, it's 2ab. So what I need to do is here, I need to, just like we did before, we add b squares, right? So this is 3/2 to the what? To the squares. Okay, now let's do the y part. So this is plus y squared plus y, right? Plus square plus y here. Okay, so the same way here, I need to do 2ab. So I need to change this to 2 times ab's, right? So What is will become 1, so 2 times 1/2 y's here, right? So now this is 2ab, so this is my b's here, 1/2, right? So now I can plus, so this is plus sign, so I can plus 1/2 to the square. Okay, that's what we mean to the complete square. Okay, so now take a look here. My right-hand side is 45, right? And I can just, so here I add 3/2 to the square. I add 1/2 to the square. I cannot just randomly add numbers into my equation. So what I need to do here, I need to add back, right? So I need to add back, this is 3/2 to the square plus this is 1/2 to the squares, right? Okay, so now in here, now I can rewrite this ones here. So finally, this is x minus 2ab. So we know the a minus b square is a square minus 2ab plus b squares, right? So for the first ones here, let me still use the color coding, maybe it will help. So for the first part, complete the square, I can rewrite this is x minus b, so a minus b, so it's x minus 3/2 squares, right? Okay, then plus, I can do the same way here, the complete square for the y part. So this will be 2ab's, right? So it's add, so it's y plus what? Y plus 1/2 here, right? Okay, very good. And I'm sorry here, forgot the squares here, right? Okay, so in here, now let's take a look at what is this one. So this is a 45 plus 9. Oh, I'm sorry, this is a 45 divided by 2. Hey, I'm not careful, right? So 45 divided by 2. All right, so the 45 divided by 2. All right, so then this is 9 over 4 plus 1 over 4. So this will be 45 divided by 2 plus 10 divided by 4. So what is it end up to be? End up to be 25. It's pretty cool, right? So this one here is a 25. Okay, so now I finally get my equations here, right? So this equation is x minus 3/2 to the square plus y plus 1/2 to the square is equal to 25. So 25 is 5 to the square. So what is the radius? So the radius is what? R squares, right? A radius is R square. So radius is what? Radius is 5. Okay, so what is the center? So remember, it has to be minus, right? So this one here is 3/2. It's very good. So what happened to the y? Y is y plus 1/2. So we need to change. So what is the, so this is negative 1/2, right? The reason why is because this term, you can rewrite this is y minus negative 1/2, the whole thing squares, right? So that's why the center here is negative 1/2. That's it. That's it for the complete the squares here, okay? And now let's take a look at the next problems here. So those are the type of the problems going to happen in the SAT. Personally, I think it's a very good problem because they also test your complete square skill you learn in the algebras, right? Okay, so now let's take a look at our next ones here. Okay, so the next one's here, this one, okay. So this one's here, the equation x plus 3, y minus 1 equal to 25. Which of the following points not inside interior of the circle is here? Okay, for try to do this one, we have, I can show you a quick way and then in other ways here, you know, so if you can find, so because they say which point not in the interior angles, right? Okay, so the first things here, I know the centers here. center, so it's negative 3 and 1, right? So that means now the radius here is 5, okay? So the center, this is the x coordinates, this is the y coordinates, right? So because the radius is 5, so I know my x values, right? So my x value has to be from negative 3, you have a 5 radius, so it's what? So it's 2, right? Then from this is negative 8, right? Okay, so maybe I shouldn't skip the step. So let's see here. So I know the x here, because the rate x, the center start negative 3, so it's negative 3 plus 5. Then you go back, so this is negative 3 minus 5. So that's why the x here, so x here is what? Oh, I kind of, I think I accidentally, I accidentally kill my, that's not good. I accidentally kill my equations here, but that's fine. We can do that, no problem. See here. Okay, so I just need to be careful. This Zoom sometimes. So if I'm not careful, I erase my problems here. So x is negative 8 and 2. So the same way, the y, so the y is from what? Y is from 1, you go up 5, and 1, you go down 5. So y should be from the 6 to negative 4. Okay, so the possible answer choices here, right? So the possible answer choice, I accidentally erase this. This is negative 7, 3, and the B's here is negative 3, 1, and the C's here is 0, 0, and the D's here is 3, 2. Okay, so the first quick and easy way is to check. To check, is any number is not, is not inside my x and y ranges here. Since this is multiple choices, right? So as long as you find the one, then that's it. Okay, so in here, the first one is negative 7 and 3. X, negative 7 is inside here, 3 is inside here. Then the next one here is negative 3 and 1. So negative 3 is here, 1 is in here, 0, 0, x is in the range, y is in the range. Then this one here is 3 and the 2 is here. So 3, x is only can go to the 2. So the 3 2's here. So obviously this number, so this point is not in the interior. Okay, so this is the quick way to check. So this one is not in the interior. And, if sometime, they give you all the numbers all within. So doesn't mean like x is inside, y is inside, then that point is going to be inside, right? So the way you check, you can substitute the number into your equations, right? So your equations here, this is x plus 3 to the square plus y minus 1 to the square is equal to 5, right? Okay, so you can plug in. So for the negative 7, so it's a negative 7 plus 3 to the square plus 3 minus 1 to the square. So what is here? Negative 7 plus 3 is 4, right? 4 to the square is 16 plus what? 3 minus 1 is 2. 2 to the square is 4, so it's 20. Okay, so 20 is less than what? 25. So that's why this one is inside the interior. That will be maybe it's more rigorous way to check, right? So, but this, like in the SAT, as long as you can find a quick way, so we can know that. So negative 3 is here. So let's take a look at negative 3. So this is negative 3 plus 3 to the square plus 1 minus 1 to the square oh, this is 0 plus 0 is 0, so it's less than 25. Obviously, this point is inside the interior. Then the next point here is 0 zeros, right? So use this 0 plus 3 to the square plus 0 minus 1 to the square. So what is here? So this is 9 plus 1 is 10, right? So this one obviously less than 25. So I know this one is, okay, so for these ones here, we did from the quick check, right? So we say, hey, this is not interior. Let's see, it's true or not. So I put the 3s, right? So this is 3 plus 3 to the square plus 2 minus 1 to the square. So 3 plus 3 is what? 6, right? 6 to the square is 36 plus 1 is 37. So it's greater than 25. So that's why I choose these answers here, right? So that's why we say this is not interior. So depends, you know, you can use this one, this quick way to do it. As long as you see a 1 point is outside, then you know it's not interior. But sometimes, like I said, if all the points are inside, doesn't mean, you know, like if the x and the y coordinates is inside this range, doesn't mean the point will be inside, right? So then you better check each point. But as long as you find the like x coordinates is outside or y coordinates are outside, then that's it. You can do that. Okay. Okay, so now let's take a look at the next problems here. We say the circles below have a center. And oh, here, I think they missed a word here, and the radius here is 10. Right, so I think I forgot to put these ones here. So I want to find what is the value of case here. So if this is center, right? So the center, so this is radius and this is radius, right? So because from the center to any points of the circumference, it is radius. So I know, so from the distance formula, so I know the radius is equal to, right? So it's h minus 4 to the square plus k minus 0 to the square equal to 10, right? So to simplify this, we can take the square roots out. So this is h minus 4 square plus k square equal to 100. Then we can find another radius. Another radius is equal to h minus 20 to the square plus k square equal to 10, right? So I can simplify these ones here is h minus 20 to the square plus k square equal to 100, right? So now I have two equations. So if you put these two equations together, right? So I'm going to solve these two equations, right? So what I can do here, like we did before, you say, hey, I'm going to minus these two equations, right? So when you minus these two, you will get h minus 4 square minus what? Minus h minus 20 what? Square is equal to what? Is equal to 0, right? So now you can do, this is a square minus b squares, right? Wow, that's good. So I can say here, this is h minus 4 minus h minus 20 times h minus 4 plus h minus 20 equal to 0, right? From here to here, what I use here, I use this formula, a squared minus b squared is equal to a minus b, a plus b is here. All right, and this is my a, this is my b's, right? So that's why I can simplify it. Okay, so now let's be careful about our algebra. So this is s minus 4 minus h, negative is what? It's positive. Right, so this is h minus 4 plus h and minus 24. See here is equal to 0, 20. See here, I'm not careful and I try to go fast. Okay, so this is 20s, right? Okay, so now I can see here. So now here this will be H. So this is so this numbers here, right? So this is the H minus H is going to cancel, right? So that means here I'm going to have what? 16 times H plus H is 2H minus 24 equal to 0. So what I can get, I'm going to go over here because I run out of space. So the 2H minus 24 equal to 0. So I have H equal to what? H equal to 12, right? If I have H equal to 12, then I can substitute back to my equations here. So I can substitute back to these equations, right? So I can say 12 minus 4 to the square plus k square equal to 100. So 12 minus 4 is 8, right? So 64 plus k square equal to 100. So k square equal to 36. So k equal to 6, right? So I know my radius, my centers here. What is my centers here? Will be 12 and what? 12 and 6 here. All right. So for this province here, we use the what? We use the distance formula again, right? We use the distance formula again, and then we solve the system of equations. That's what we did past. Okay, so those are very good problems here. Okay, now let's take a look here. The next one's here. The equation of the circle is x minus 6 squared plus y plus 5 squared equal to 16. So for these equations here, so this is x minus 6 squared plus y plus 5 to the square equal to the 16, right? 16 is 4 to the square. So I know the center. Okay, so one more time, everybody know what is the center here? So it will be the 6. So what happens if here is plus 5? We need to put a negative, right? So, and what is the radius here? Radius of 4. Okay, so now let's say if PQ is the diameter of the circles, right? And have a coordinates is equal to 10 to the negative 5. So let's take a look here. Okay. Here's my circles here. So this is my center. So this is 6 and negative 5. All right. So let's say the P is on the circle and has the coordinates. So be careful here. Instead of just jumping to try to find the distance. So take a look here. This is the y coordinates, and my center y coordinates is here. All right. So I know the P has, so the 10 has to be here somewhere, right? So this one here has to be 10 to the negative 5, and the y way, you know, the y, the height of the y has to be equals, right? Because this is the negative 5, this is negative 5. So I know this will be, right? So this will be my what? PQs, right? You see here? So because the y coordinates is the same, so that's why I know here is the, so that's why, and also we know this radius is 4, so that's why x become 10 to the negative 5. Because this is the diameter, so Q has to be on this line. So what is the Q's coordinates here? So the Q's coordinates here, right? So the y has to be the same because they are in the same lines here. Then because here is the center is 6, then you go back to 4 units. So what is the x here? 2, right? So I know the coordinates of the Q is equal to the 2 and the negative 5. So the similar problems can be given in the SAT. They could give you, yes, like something like they have the same x coordinates, right? So they could give you is something like an x coordinates, and then you want to find the Q. So if x coordinates, that means the y coordinate is going to change, right? So that's the similar problem, and for the College Board, they can switch the numbers and try to do it, right? Okay, so these are the 7 problems. The first video is a little bit long, but you know, those are the very, very important problems here. And we saw those type of problems happen frequently in the SAT exam. So make sure if you're still kind of rusted with your complete square, make sure you know how to complete the square. And also, you know, the distance formula, if you kind of rusted on the distance formula, make sure, you know, you practice that as well. Okay, that's it. So we're going to stop here for our video number 1. And we're going to start a video number 2. The video number 2, personally, I think is kind of like easier than the video number 1 because basically it's similar like our similarity concept, right? So the proportion have to be like if the sector have to have a certain proportion to the whole circles here. So personally, I think the video 2 will be a little bit easier. Okay, so it's a very nice talk to you on this video. Make sure you reviewed it several times and you kind of fully understand and remember the formulas here, right? And know how to apply it. Okay, so if you like the video, and feel free to subscribe it. And if you have any questions or someplace still get confused, you can leave me a comment and I will try to answer your questions here. Okay, so it's nice to talk to you and you have a good day, and I will talk to you in our next videos. Okay, bye.